Today we're working on the Unit 5B review. The Unit 5B test covers notes from sections 13.2 to 13.4b. So those are the sections in your notes that you want to be using to help you work on this review and to study for the test. Question number 1 asks us to evaluate each of the following equations. Notice that they all have absolute value bars, so all of them will have something to do with absolute value. And it wants us to evaluate them for each of those values of x. I really don't have enough space to do that on this paper, so I'm going to go ahead and switch and do the workout on a separate piece of lined paper, which you're more than welcome to do. Just don't forget to staple this page to the other page if you do this. Anytime you're being asked to evaluate something, evaluate means you want to take the number and you're going to plug it in. So for this one, it wants me to out-evaluate f of x, the function, is equal to the absolute value of x, for x is equal to -3. So the number that comes after the x is the number that I'm going to come over here and plug in. F of -3 just means that I'm going to plug in -3, and then that's where I plug in the -3. When you evaluate absolute values, anytime a number comes out of absolute value bars, it always comes out as a positive, and so the absolute value of -3 would be +3, and this would be your answer for part A of that question. For part B, I'll follow that same pattern. For this one, I'm plugging in a -5. So I'll say f of -5. That just means that I'm getting ready to plug in a -5. And then I'll come over here and I'll plug in a -5. When I follow PEMDAS to simplify this, I start inside my parentheses. So f of -5 is equal to -10 minus 1, or the absolute value of -10 minus 1. So f of -5 is equal to the absolute value of -11, and then once I get this down to one number, then I can take it out of the absolute value bars. So f of -5 is equal to +11, and that's my answer to the question. When you're doing these, you want to get them down to one number. Notice that they don't have any x's left in them, because you always take the number that's over here and you plug it in for your x. Lastly, for letter C, this one says f of -8 is equal to the absolute value of -8 minus 4. Now, before I can put the two of these together, I need to recognize that the -8 is inside the bars right here. So my next step is going to be taking that out of the absolute value bars. The absolute value of -8 is +8, and then 8 take away 4 gives me 4. And so my answer for part C of this question is f of -8 is equal to +4. On question number 2 on the review, there's two questions. It gives you a picture of a graph, and it says, what is the equation of the function, and then what is the vertex? I'm actually going to answer these out of order. The vertex is this point right here on the graph, and so it's like the bottom part of the V in this particular graph. And so the vertex went 1 to the left, and then it went up 1. So the point for my vertex is going to be -1, +1. So this is the coordinate of the point of the vertex. Your vertex is always going to be in x, y format. The other part of this question that's a little bit trickier to answer says, what is the equation of the function? So there's a couple things that you want to remember and recognize when you're writing down this equation. The equation is going to start with y is equal to, and then lots of things to recognize. So number 1, this V-shaped graph is facing upwards, which means the number that comes in front of the absolute value bars is going to be positive. The next thing that you would want to do is you would want to check the slope of these lines. So each side is going up 1/1, and then this way it's also going up 1/1. So that means that it's not being stretched or compressed at all, so you don't have to put a number in front of the absolute value bars. I keep saying absolute value bars because this graph is a V-shaped graph, and so I know that when I write my equation, I'm going to have to put bars on my answer. And so for this one, if it went 1 to the left, remember inside is opposite, so it's not going to be x minus 1 if it goes 1 to the left, it's going to be x plus 1. The inside number is always the opposite of what you think it would be. And then it went up 1, and so the plus 1 goes on the outside. So y equals the absolute value of x plus 1 would be the equation that would move the parent function to where this one is located. Question number 3 asks us to do the same thing, so I'll do these two out of order as well. I'm going to start by finding the vertex. Remember, on this one, the vertex is where the V turns around. For this one, it's the highest point on the graph. It's a maximum. So my vertex for this one is +2, +2. And then once I know the vertex, now I need to find the equation of the function. So it's going to start with y equals, and then because it's a V-shaped graph, I know it's going to have absolute value bars in it. This one, though, the v is facing upside down, and so that's how I know that I'm going to need to start with a negative. I count the slope, down 1 over 1, down 1 over 1, and so that means that there's no stretches or compressions happening to this graph, so I don't need to put a number out here, just that negative to show that it's flipped upside down. Inside is opposite, so when it moves 3 to the right, it's going to be x minus 2 on the inside of the absolute value bars, and then it moved up 2, and so it'll be a plus 2 on the outside. Something I want to point out about these two problems is the left-right shift that happens on the inside of the absolute value bars, that's always the opposite sign of whatever the x value of the vertex was. And then the up-down shift that happens on the outside of the absolute value bars, that's always going to be the same sign as whatever the y value of the vertex is. Question number 4 is really similar to questions number 2 and 3. The thing about it that's different, though, is that instead of giving us a picture of the graph, we're being given a verbal or a written description of how the graph is moving, and then we're being asked to write the equation that follows. So from the parent function, f of x is equal to the absolute value of x, if the graph is going down 3 units, we need to think about where the 3 goes, whether it's plus or minus, whether it goes on the inside or the outside, and kind of how that equation would look. What these 3 answers are all going to have in common is they're all going to have an absolute value of x as a part of the problem. So for this one, if the graph's going down 3 units, it's going to be the absolute value of x minus 3. The minus 3 has to come on the outside of the absolute value bars because the up-down shift happens after the absolute value. It can't go on the inside or else it would be wrong because that's where the left-right shift occurs. On letter B, if the graph is shifting horizontally left 4 units, the 4 is going to have to go on the inside of the absolute value bars for this one. So that's the first thing that you want to keep in mind. The other thing is, if it's going left 4, inside is always opposite, and so it's not going to be minus 4 to the left. It's going to be plus 4 to the left. By the way, all of these would be wrong if you forgot to put the absolute value bars on there, so make sure that you do that too. That tells you what kind of graph it is, so it changes the kind of graph from being linear to being an absolute value function. On the last one, it says the graph is reflecting over the x-axis, which means it's flipping upside down. So that's how I know on this one I'm going to need to start with a negative. And then it's going 2 to the right. Inside is opposite, and so it's going to be x minus 2 on the inside. When you're doing these shifts, you do want to remember that the number that's on the inside, whether it's moving it to the left or whether it's moving it to the right, is sort of the opposite of the sign that you think it would be. But if it's moving it up or down, that's the same sign that you think it would be to create that shift. Questions number 5 and 6 on the review ask us to solve these 2 absolute value equations. And so to do these, I'm going to shift and go onto a separate piece of paper so that I have a little bit more space. You would expect to get 2 answers to the question, although sometimes you could get 1 answer and sometimes you can get no answers. Remember that you can't split it off and make your 2, though, until after you get the bars by themselves. So on this one, the first thing that I'm going to do is I'm going to divide both sides by 3. When I do that, this 3 that's outside in the front, that's being multiplied by this, crosses off with that 3 that's underneath. And so I have the absolute value of 2x plus 6 is equal to 12. Now this is ready to split and make my 2. I'm going to take what's on the inside, so I'm dropping the bars in this step. So 2x plus 6 with no bars is equal to positive 12. That would create one solution. And then what's on the inside here, 2x plus 6, could also create, or could also work out to be negative 12, and that would create another solution for x. So when you solve these, just go nice and slowly and be careful to show all your work. For my first answer, I'm going to get x is equal to positive 3. And then for my second answer, I'm going to get x is equal to negative 9. And so these are the 2 numbers that would create solutions for this equation. If I plug in a negative 3, it would be true. Or excuse me, a positive 3, it would be true. And if I plug in a negative 9, it would be true. Similarly, for number 6, I'm going to follow that same pattern. It's not ready to split off and make 2 until after I get the part that's inside the absolute value bars all by itself. So for this one, I'll start by adding 6 to both sides. And then it's still not ready to split off and make 2 because I have this 2 out front. So I'll divide both sides by 2, and dividing it by 2 makes the 2 cross off that's out front. So I have the absolute value of x plus 8 is equal to 7. Once the part that's inside the absolute value is all by itself, now it's ready to split it off and make 2. You want to really resist trying to show your work right here on the problem, because oftentimes when students do that, they forget to do their second equation. So remember the pattern. What's on the inside of the absolute value bars could work out to be positive 7, and that would give you one answer to the question, or what's on the inside of the absolute value bars could work out to be negative 7, and that would give you another solution to the question. And so when I solve this one, I'm going to get x is equal to negative 1, so that'll be one of my answers. And then when I solve the other one, I'm going to get x is equal to negative 15, and that would be my other answer. When you solve absolute value equations, usually you get 2 answers, but it is helpful to point out that sometimes you could get one answer if this number right here was the number 0, or you could get no solution if this number right here was a negative number. And so it's good to see the pattern for how that works. The directions for question 7 are a little bit different than the questions that we've done so far in our notes. It asks you to solve this, but using sort of a different approach to asking you to understand the question. So let's make sure we understand that first. It says choose the value for k from the given list of values so that the equation here has the required number of solutions. So they want to know for this answer, or for this answer, which one would make this equation have 2 solutions, which of these answers would make this equation have 1 solution, and which of these answers would make this equation have no solution. And so when we're doing our work for this one, we have to keep a couple different things in mind. If the number that comes, well, here, let's get started with it first. The first thing I'm going to do is get the absolute value bars all by themselves. And so to do that for this problem, I would add the 3 to both sides. I can't combine k and 3 together, so I'm just going to write it like this. And then that's where you want to pause and kind of think about what's happening. The absolute value bars are all by themselves, and they're set equal to this expression k plus 3. And now we have those 3 other numbers for k that we sort of have to think about. But this is a place where you want to stop and think about how absolute value works. If the absolute value is set equal to a positive number, so if k plus 3, let me circle that part. If k plus 3 were positive, that means the equation is going to have 2 solutions. Because you'll split it off, you'll make one be positive, you'll make one be negative, and you'll solve it from there. If k plus 3 works out to be the number 0, that means that the equation is going to have 1 solution. And if k plus 3 works out to be a negative number, that means that this equation would have no solution. Because you can't have the absolute value work out to be a negative number. So if you wanted to, this question does not ask you to figure out what the answers to the question would be for each of these situations. It just wants you to figure out which number for k would make which thing happen. And so when we're looking at our 3 different values for k, we have k equals negative 7, we have k equals negative 3, and we have k equals negative 1. And so what I can do is, instead of plugging it into this whole thing, I could just plug it into the red part, and then I could use this to help me answer the question. So if I did k plus 3 and I plugged in the negative 7, let's see. Negative 7 plus 3 would give me negative 4. So that means if I plugged in a negative 7 right here, I would get negative 4 out. That would mean that the absolute value of 4 plus x would be equal to a negative number, and that would cause this equation to have no solution. If I plugged in the number negative 3 to this expression up here, negative 3 plus 3, I would get 0 out as my answer. So then I would have the absolute value of something equaling 0, and that means that the answer to the question would have 1 solution. And then lastly, if I plugged in the number negative 1 into that expression, negative 1 plus 3 would give me positive 2. So that would work out to have the absolute value equal to a positive number, and that means that I would work out to have 2 solutions to the question. And so answering this question on your review, it wants to know which number for k would make it have 2 solutions, and so we figured out that that would be when k is equal to negative 1. We wanted to figure out which answer for k would have there be 1 solution, and we figured out that that was when k was equal to negative 3. And then which answer for k would have there be no solution, and we figured out that that one was when k was equal to negative 7. There's plenty of other ways to understand the answer to this question. This is just one of the ways that sometimes students think is the most logical, and it also involves the least amount of work. Questions number 8 and 9 give us an absolute value inequality. It wants us to solve it, and then it also wants us, when we're finished, to list 3 possible numbers that would be solutions to the question. So I'm going to go ahead and do my work for this one on a separate piece of paper as well. The first thing you'll notice is that this is written sort of backwards. Most of the time, the absolute value part comes on the left, and then the number after the inequality comes on the right. So it's optional, but if you want to, you could take this whole thing and flip it around. Now, what you want to be careful on, though, is when you flip it, remember this is an optional step, but when you flip it, if you're putting this on the other side, it's not going to say greater than or equal to anymore. It's going to flip, and it's going to say less than or equal to. So one of the things that you should start by recognizing in this problem is that it looks like it's going to be a less than symbol, and so less than is your wink, wink, nudge, nudge on how your answer to this question is going to look. But we want to get the bars all by itself before we make that decision. So on this one, I'll add the 8 to both sides because I know I have to get the bars all by themselves before I can do the problem. So the absolute value of x plus 4 is less than or equal to 12. So a couple of things. This means that the absolute value has to be within a range of numbers. So it has to be inside of some constraints. That's how I know that this is going to be an and problem. Your teacher might have also given you the clue that when this is a less than symbol, there's sort of this like cheesy way that we help you remember it. And we say that if it's less than symbol, you know it's going to be an and problem because less than is just a way of remembering that. Math teachers are lame sometimes. We apologize in advance for that. So if it's going to be an and problem, that means that the negative 12 is going to come over here. The x plus 4 is going to go in the middle and you drop the bars. And then the positive 12 is going to come on this side. This problem says that you want x plus 4 to be within 12 and within negative 12 of x plus 4. So it's saying you want the answer to be on the inside of these numbers. I'll minus the 4 from all 3 parts. And so I'll get negative 16 is less than or equal to x is less than or equal to 8. So this is my answer to the question. This particular problem does not ask for me to graph my answer to this question, but I think that graphing it would help you answer the last part of the question, which is picking numbers that work for your answer. So if your answer has to be between negative 16 and positive 8, I'm not going to draw all the numbers on the number line, but so this would be negative 16 over here, 0 is the middle, positive 8 would be somewhere over here. Again, this is just a quick sketch of the number line. And so my answers for this question would be all of the numbers that are within those values. And so part of your answer to this question wants you to list 3 solutions or 3 numbers that would be an answer to this problem. And so when you list your 3 solutions, you can pick any 3 numbers that are within negative 16 and positive 8. And so when you pick your 3 numbers, you're going to go ahead and pick the numbers that make the most sense for you. Go ahead and ask your teacher if you're not 100% sure of how to answer this question, but you're finding 3 numbers that are in between negative 16 and positive 8. And on this problem, it actually can include negative 16 or positive 8 as well, but any numbers in here would be answers to the question. Question number 9 is set up similarly. I'm going to go ahead and minus the 2 from both sides. Notice on this one I didn't have to flip it around potentially because this was already on the left. So it'll be the absolute value of x minus 7 is greater than or equal to 14. And so this is where I want to pause and stop. I have the bars all by themselves. This says greater than or equal to. If we want something to be greater than or equal to the absolute value away from something, it means it's going to be on the outside of 14 away from this, and then on the outside of negative 14 away from this. So that's one of the ways that I can help myself decide that I know this is going to be an or problem. The other way that your teacher might have taught you is that when you see that it's a greater than or equal to sign, we have that cheesy way of helping you remember it. So we say it's a great or problem. And so that's how you know that you're going to set your work up as an or problem. So for this one, I'm going to say regular x minus 7, so no more bars, needs to be greater than or equal to 14, or regular x minus 7, no absolute value bars, needs to be less than or equal to negative 14. Make sure that you see on your papers that the direction of this sign switched directions, and then this one said positive 14, and this one says negative 14. So it's kind of like this one switches and to the opposite direction, and then this one switches to the opposite sign. You'll solve these each individually. And then when you get the two parts for your answer, we write them together. And so it's going to be x is greater than or equal to 21, or x is less than or equal to negative 7. And those can get written in either order. You just want to make sure that you're careful for the direction of the sign. Again, this problem did not call for you to graph your answer, but graphing your answer can help you when it comes to understanding the next part of the question, which is going to ask you to list 3 answers as well. So 0 is in the middle. The first part says x is greater than or equal to 21. So that goes this way. And then the second part of the question says, or x is less than or equal to negative 7. And so that part of the answer would go this way. So for question number 9, when you list your 3 solutions, you're going to be looking at the graph, and you're trying to pick 3 numbers that would be answers to these questions. And so again, for this one, you're going to come up with these 3 numbers on your own. Answers for this question would be anything that's bigger than or equal to 21, so any numbers that are greater than 21, or any numbers that are less than or equal to, so smaller than or equal to negative 7. So you're picking numbers that are in the parts of the graph where the arrows indicate have answers to the question. The last question on the review, question 10, wants us to first graph the function, and then it wants us to write down what's the domain of the function and what's the range of the function. So when I look at the function, there's a couple important things that I notice. I know that this isn't going to be a parabola. I know it's not going to be a straight line. I know that it's not going to be any kind of a weird graph because I see these absolute value bars, and so that's right away how I know the graph is going to be a V-shaped graph. So when you graph this, you know your graph has to look like the letter V. There's a couple of other things, and I like to write these down using words, so I'll do that down here on the bottom of the page. I see that this graph has a negative out front, and so the negative out front is how I know that the graph is going to have a reflection. So it's going to be flipped upside down, and so that's again because of the negative. The next thing that I notice about this graph is there's a +3 on the inside. Remember that inside is opposite, so if it's a +3 on the inside, that means it's going to move 3 to the left. And then the last thing that I notice about this graph is that there's a +1 on the outside, and so that means that it's going to move up 1. So I do want to remind you that the number on the inside is always the opposite of the direction that you would think, but the number on the outside is always the same direction for what you would think. This number on the inside moves it either left or right, and then this number on the outside moves the graph either up or down. So I always start by moving my vertex. Something for this graph that you may choose to add. Remember, the parent function, or the regular graph that you're graphing, is the graph y is equal to the absolute value of x. And so some students kind of benefit from seeing where that graph started from. This is not the answer to the question. That's just where the regular graph started. This graph is going to move 3 to the left. I'm moving my vertex, by the way, when I move it. So 1, 2, 3 to the left, and then it's going to move up 1. And so that black point that I just put on my graph right there is where my new vertex is going to be. If this graph didn't have a negative out front, it would stay facing upwards. But because it has a negative out front, that means it's going to flip downwards. So it's going to be going in the opposite direction. So when you do this, you're going to go down 1, 1 to the right, down 1, 1 to the right, down 1, 1 to the right. And so that pattern would continue. And then you'll also go down 1 and 1 to the left. And that pattern would continue. These graphs are not correct unless you include or unless you draw that the points on the graph. So make sure that when you're graphing it, you include those points that are on your graph when you go through and when you label it. And then, using a ruler, which I didn't do on the regular one, you'll go ahead and draw in this graph. By the way, it's fine to leave the light one that we did here on the graph if you like seeing that first one for where the regular graph started. But make sure that you have this one drawn in either in a different color or you indicate that this is the actual graph that you moved. So drawing this one is optional, but drawing that one is required. Domain is the x values and your range is your y values. And so your teacher might have taught you a couple different ways to write these, so I'll make sure that I cover all of them. For domain, the domain is for the function are the numbers that you can plug in for x. So this graph stretches forever to the right, and it stretches forever to the left. And so for your domain, it's all real numbers. So a couple different ways that teachers can teach you how to write that down. You can write the words all real numbers. So that's one way that you could answer the question. There's also this fancy letter R that you can draw, and that means the same thing as all real numbers. And then there's another way that your teachers might have taught you how to write it. Well, there's two other ways. You can use this parentheses interval notation if you want to. If your teacher didn't teach this to you, just don't worry about it. And then the last way that you could do all real numbers is you could say it's the set of all numbers x such that x is anything you want it to be in between negative infinity and positive infinity. So don't get concerned about remembering all of these things. Just look at your notes, and whichever way your teacher had you write it down, you can follow their directions for that. The range is my y values. And so for this one, the range isn't everything. Look at the graph. You can look at the graph and see that the highest the graph goes up, and again, we're just looking at the black one for this, the highest the graph goes up is the point right here where y is equal to positive 1. So for the black graph, for the real transformation, the graph never goes any higher than positive 1. It goes from anywhere down here, right? Because this is going to keep going down and this is going to keep going down. It comes from way down here all the way up, but positive 1 for y is the highest that it goes. And so there's a couple different ways that you can write that down as well. For your range for this one, you could say your range was all of, oops, that's the wrong direction. You could say that it's all of your numbers for y, such that y is less than or equal to positive 1. Or you could write it this same way. So you could say the set of all numbers y such that y is less than or equal to positive 1. And then there's a way that you can write it too with this interval notation. And then this would need a bracket. But again, try not to worry about remembering all of these different ways to write it. There's 4 different ways you could write your domain, and then there's 3 different ways that you could write your range. What I would recommend doing is go into your notes, see the way that your teacher had you write this down. Let me just draw a line so you know these are separate from each other. Go into your notes, see how your teacher wrote these down, and then practice writing domain and range the way that your teacher taught you. Or pick one of these that makes the most sense to you, and you can always practice writing it that way. The big thing to take away from this problem, though, is that the domain is everything, and then the range is just the numbers that are less than or equal to positive 1.